Welcome back, everybody. In this next set of videos, we're going to do something called verifying trig identities. And what we're going to do is we're going to take identities that we already know, that we're already familiar with, and use them to verify new trig identities. And the way we do it is really by a lot of substitution and making changes. And you'll see as we go through, it's almost like combining algebra and trigonometry, where we're working with equations a little bit now, and we're trying to kind of manipulate those equations to make them look like the right-hand side. So I'll show you, and I think it'll make a little bit more sense once you see some examples. What I have already written down here, and again, you may want to pause the video if you don't have these already written somewhere that's easily accessible. I know you probably have these in your notes, but now could be a good time just to write them all in one spot. So maybe one note card, or a lot of times students will use the front or back page, back cover of their notebook, where they put their important formulas or things. So these are things that you want to have easily accessible for the next set of videos. So these are your fundamental trig identities. Again, we've already seen all of these. So the first set are your reciprocal identities, right? Sine is the same thing as 1 over cosecant, cosine 1 over secant, tangent 1 over cotangent, and then similarly, cosecant is 1 over sine, secant 1 over cosine, and cotangent 1 over tangent. For your quotient identities, we know that tangent is sine over cosine, or cotangent is cosine over sine. We've seen the Pythagorean identities as well. So the most common is sine squared plus cosine squared equals 1, but the others are also helpful. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. And then we've also talked about even and odd as well. So your even functions are your cosine and your secant. So if you plug in a negative, you just get the positive version back out. It makes no difference. The rest of them are all odd. So for sine, cosecant, tangent, and cotangent, when we plug in a negative, that negative can come outside, and then we can find just the sign of the x value, etc. And again, these are all things we've already seen in previous videos. So if you don't have them written down, not just written down, but easily accessible for you to keep looking at, I suggest pausing the video, put these on a little note card for yourself so you can have them with you. You're going to want to have them on hand, and you're not going to want to be flipping through for this section and the next few videos, and of course the homework that goes with it. So what we're going to do is we're going to go ahead and we're going to use these identities to help us verify other trig identities. So we're going to kind of show that other trig equations are also true. To verify an identity, what we do, it's not quite the same as proving an equation, it's a little bit different, is we show that one side of the identity can be simplified so that it is identical to the other side. So what we often do is we'll just focus on one side of the equation, which is the identity, manipulate it using our common identities that we just saw, and get it to look like the other side. That's our goal. Sometimes if we can't do that, we will manipulate each side independently to get them to match to something different. And I'll show you one of those later on, not quite yet. But ideally, you're trying to work with only one side of the equation and to get it to match the other side. That's usually what we end up doing. So let me show you some examples. All right, I don't know why my E looks so weird, but verify the identity, that's one word, and it's going to be secant x cotangent x is equal to cosecant x. Now, when there's no symbol in between, it is multiplication. So the way the problem's written is like this, but it does mean multiply. So if you find it helpful to put that in, you can go ahead and do that. But know that if they're touching like that, it's just multiplication. So verify the identity, again, doesn't mean to solve for x. It means to show that the left and the right-hand side are actually the same. That's what we're trying to do. So you want to pick one side to start with and think of these like puzzles. They really are puzzles, and you want to manipulate it to get it to match the other side. Doesn't matter if you start with the left or the right side. You're going to kind of pick whatever seems to be easier for that problem. In this case, it's going to be easier for us to start with the left side. And again, we're just going to try different things to see if we can get it to match the cosecant. So one thing, a lot of times we do like our reciprocal identities. So secant is the same thing as 1 over cosine, and cotangent is the same thing as 1 over tangent or cosine over sine. Usually you're trying to get things to cancel and stuff. So you probably want to pick this one here because that kind of matches with the 1 over cosine idea. So oftentimes, again, try to pick things that look similar because we're usually trying to get stuff to cancel. So I'm going to change secant to 1 over cosine of x. And then I'm going to change cotangent to cosine of x over sine of x. And what you're going to notice then is that the cosine over cosine will cancel, and I'm left with 1 over sine x. But 1 over sine x, by definition, is cosecant. And this is what we were trying to show, right? We were trying to show that this is equal to this. And we did that. So we took one side of the equation to start with, not both. One side to start with. We tried some different tricks, tried some different identities. Sometimes it's a little bit of trial and error. They're like puzzles. And then you want to see if you can manipulate it to get to the right side. And here we did. So we are done. Now I did this more horizontally. If you prefer to do it vertically, you can do that too. So just a little side note here. Sometimes people prefer to write it vertically instead. So by that, I mean kind of doing each step downward. So here you would notice your cosines cancel, and then I would write 1 over sine x, and then I would write cosecant x. And that's another way to set it up. It doesn't matter if you do it horizontally or vertically, as long as you can keep track of all your steps along the way. Now, the process that we're doing here is algebraic, right? So we're showing through some algebra steps, really, trig steps, algebra steps that these two sides are the same. You can use other techniques, so I'm not going to go ahead and spend a lot of time here, but I'll just make a little note. Let's see if I can get this on the screen. That you can also verify things graphically. So a nice thing to do is you could actually graph the left side of the equation, then graph the right side of the equation and make sure the graphs match. And that's a great way to do it using Desmos or a graphic tool, really easy. So you graph each side separately, like pretend like they're their own equation, and you should see that the graphs lie on top of each other and they match. So that's another way you could check graphically to make sure that you're on the right track. And you can also check by table, so you can plug in a whole bunch of different values and actually see if you get the same answers. This is not as rigorous as doing a full graph or doing the algebra. But it's just a nice way where, maybe you're not sure it really is an identity, graph it first. And then if you see that the graphs are the same on each side, now you know to proceed with the algebra. So it's just a good little tip and a good little check that it's worth actually going through the algebra steps for some of these questions. All right, I'm gonna do another one. And I'm keeping my my reciprocals sheet, my fundamental identity sheet close by. So I'm going to keep that near me just so I can, use it for reference here. All right, so we're gonna do another one. Verify the identity. Sine x times tangent x plus cosine x equals secant x. It's usually easier to move from the side of the equation that has more stuff than to the side that only has one. So I recommend here starting with the left-hand side. And like I said, if I see tangent and I see lots of sines and cosines, my inclination is to make that tangent sine over cosine first, and then see what else I can do after. Doesn't work 100% of the time, but a lot of the times we're trying to cancel things out, right? I'm going from a much larger expression or longer to something very simple. So I want to get things to cancel to get this down to just a secant. All right, so I'm going to start with the left side here. That's what my suggestion is. Again, if you have a longer side, you should start that one. And I'm going to change that tangent over first to sine over cosine. That's just my starting point because I see lots of sines and cosines. And again, it's sort of like a guess, you know, sometimes it takes you a little bit of time to kind of figure out what's going on here. So when I do that, sine times sine is sine squared. So I have sine squared x over cosine x plus cosine x. All right, I didn't really get anything that helped me too much. Another suggestion I have is when you're adding with fractions, it is too good to combine them. That's usually helpful. So I do need common denominators here. I need a denominator of cosine. This denominator is just a 1, right? So it's not really helpful. So I do need a common denominator of cosine x, but I can't just multiply by cosine x on the bottom. I have to also multiply it on the top, just like you were doing regular common denominators or fractions. So this now gives me sine squared x. Cosine and cosine is cosine squared. And all over cosine x, because now they have the same denominator. Well, sine squared plus cosine squared, that's one of our Pythagorean identities. And I know that value becomes 1. So this gives me 1 over cosine x. But 1 over cosine x is actually secant. Right? 1 over cosine x is secant. So we are done. We started with this side. And we ended with this. So we're done. It can help to use color here because sometimes you kind of get lost in all the work and the algebra in the middle. So it's good to know, you know, this is what I'm starting with. This is what I need to get to. And once I get there, I have shown that they are, in fact, this is true. This is a true equation. It is an identity. And I'm done. All right, here's another example. And again, these videos are just gonna be lots of examples on how to do this. So you can see some different strategies. So far we have talked about, you know, a lot of times with those reciprocal identities, trying to find things that cancel. So if you have tangent, I probably wouldn't use 1 over cotangent if I see a lot of sines and cosines, right? I would use sine over cosine. Or here, if you have fractions, common denominators are a great way to try to clean it up and see if you can simplify. In this next one, we're actually going to use a factoring technique, which is, you know, kind of weird. You maybe not think to use that. I'm going to start with the left side. So I'm just going to rewrite that. And then again, I don't really see any easy transitions, right? I don't have tan or cotangent, or I don't have cosecant or secant, right? Those are kind of ones that I switch over right away to sines and cosines, typically speaking, not always, but usually. Sine, I mean, I can't really think of anything to do, so I'm going to try factoring. I see that they both have a cosine in them, so I'm going to try factoring that out. So if I take it out of the first one, I just have a factor of 1 left. And for the second one, I have a factor of sine squared left. Now, this may not be as obvious to you, but we do have the Pythagorean, one of the Pythagorean identities says that sine squared plus cosine squared is equal to 1. Now, if I bring that sine squared to the other side, I end up with cosine squared x is equal to 1 minus sine squared x. So you may notice that we have 1 minus sine squared x right there. So I can go ahead and make that substitution. This becomes cosine of x. This one stays the same. And then this becomes cosine squared x. Well, cosine times cosine squared, think of it, x times x squared would be x cubed, right? So this is cosine cubed x, and that's what we were trying to get to. So we are done. So a technique I used here, I used factoring, because again, I couldn't really think of any other way to make this helpful, but I noticed they both had a cosine x in them, so I factored that out. And then I was able to manipulate one of the Pythagorean identities in order to make a substitution. And that got me what I was looking there. Now, some of these may have more than one strategy. So if you found another strategy that you think works, but you're not sure, send me an email, ask me, write it out and say, hey, does this one work too? A lot of times there's more than one way to do it. Not everything is just solely one way to do things, right? So keep that in mind as well, that, you know, there often is more than one way to do it. And that's okay. So if you think you have another strategy, but you're not quite sure if you did something wrong, send it to me via email, send me a picture and I can take a look at it for you. The key thing is that, you know, in general, you want to work with one side at a time. Notice that I'm not working with both sides and trying to manipulate both together. That doesn't work. You have to work with just one side at a time. So start with one side, go as far as you can. If you can get it to match the other side, then phenomenal, you're done. Okay. Now for this one, I think you could really start on either side here. They kind of both have a little bit going on. So I'm just going to start with the left side. But I think you could really take this from either side and work either way. So I'm going to start with 1 plus sine theta over cosine theta. Now, theta is fine. It's just also x. It doesn't matter. Whatever variable you're using there is perfectly fine. Now, here's another way to start. Normally, we like to put things together when we're adding fractions, but you can also break them back down, right, if that's helpful. So here I could break this back down and write this as 1 over cosine theta plus sine theta over cosine theta. Well, 1 over cosine theta is secant, and sine over cosine is tangent, right? So this becomes secant theta plus tangent theta, and we are done. That's what we were looking for. Again, as a little side note here, there's often more than one way to do it. So let's say that you're like, oh, I don't really like that left side. I don't want to start there. Maybe you want to start with the right side. Plus. Well, you may recognize that secant theta is 1 over cosine theta, and tangent theta is sine theta over cosine theta. And then you may say, hey, those are fractions with the same denominator. I can put those together. And you get to the left side, and that works too. So again, there's often more than one way to do this. Here I started with the left side, but in this case, again, they both were kind of complicated. So I started with the right side and I was able to get to the left. Doesn't matter. So pick whatever you think would be easier for yourself. Again, you can use entity identities we already know, and they're a little puzzle. So there's often more than one way to do it, and that's okay. Again, if you're not sure if you're making mistakes, let me know, send it to me. But we can go from either side. Usually I try to take the more complicated side. For me, that tends to work better. But again, there's lots of ways that we can do it. So let's pause this video here. I don't want it to get too long. And then in the next video, I'm just going to do some more examples.